of waterfowl lose all of their flight feathers during an annual molt, this causes them to completely lose their ability to fly, so they transition to ground locomotion. This is because there are groups of feathers on the outside of the wing called the primary and secondary flight feathers, and they are so important for flight that for some birds, the loss of only one is enough to result in flightlessness. Laying hens are commonly missing their wing feathers due to abrasions from housing structures or due to feather pecking, a behavior in which one bird will pick at and pull out the feathers of another bird. Feather pecking is a big problem as it is very common, with reported prevalences of 15 to 95%, and can result in flocks of nearly featherless birds. And missing wing feathers may be a big problem for laying hens because they are more commonly being housed in multi-tiered housing systems. In this system, they are required to fly or jump between tiers in order to access resources such as food, water, and nest boxes. But how important are the wing feathers for upwards mobility in these systems? To date, there are no studies investigating this, which brings us to our study. We wanted to know, does the loss of flight feathers impact the amount of time hens spend accessing elevated resources in a multi-tiered housing system? To answer this, we distributed 120 adult laying hens of 2 strains amongst 12 floor pens. Within each pen, we randomly assigned hens to one of 3 treatments. The first were the controls, whose flight feathers remained intact. The second were the half-clip group, in which we trimmed the 10 outermost feathers of the wings, known as the primaries. And the last group was called the full-clip group, in which we trimmed all of the flight feathers, and all treatments were applied to both wings. The pens that hens were kept in were furnished with 2 elevated platforms, 2 perches, and there were 2 feeders and 2 nest boxes. One of each was either on the ground or secured to an elevated platform. In having the pen set up this way, we wanted to know how much time hens spent accessing the elevated feeder and nest box before and after we applied treatments. So with an RFID system, we recorded the amount of time they spent at each of these resources for 48-hour intervals on week 0, our baseline measure, as well as 2, 4, and 6 weeks after treatment application. We will begin with the time spent by white-feathered hens at the elevated feeder, and just before we jump into the results, you are about to see a series of pie charts, and they represent the total number of minutes spent at a feeder for each treatment group. The blue space inside the pie chart represents the percentage of time at the elevated feeder, and the orange represents the percentage of time at the ground feeder. When you see a single asterisk, it represents a significant difference of 0.05 or less, and 2 asterisks 0.01 or less. Differences shown are within treatment groups and are comparisons from week 0. So on week 0, before treatments were applied, you can see that for all 3 treatment groups, elevated and ground feeder use was relatively even. 2 weeks after treatments were applied, you can see that the controls and half-clip maintained the same even feeder usage. However, the full-clip hens spent more than 40% less time at the elevated feeder. And these patterns of feeder usage that we saw on week 2 remain the same throughout the rest of the experiment. For elevated nest box usage, you can see that on week 0, white-feathered hens use the elevated nest box more than the ground nest box. 2 weeks after treatments were applied, the control and half-clip groups continued to use it the same. However, the full-clip hens spent significantly less time there, and as the weeks progressed, they showed a continuous decrease in elevated nest box usage. So what about the brown-feathered hens? Brown-feathered hens prefer to eat from the ground feeder, so when we applied treatments to them, we didn't see any changes to their pattern of feeder usage, which you can see here. However, like the white-feathered hens, brown-feathered hens also spent more time at the elevated nest box. But interestingly, 2 weeks after applying treatments, it was both the half-clip and the full-clip that saw a huge decrease in time spent at the elevated nest box. And as we saw earlier, this pattern seen 2 weeks after treatment application stayed in place for the rest of the trial. So results of our study found that clipping the wings of laying hens reduced the amount of time that they spent accessing resources on elevated tiers, and that brown-feathered hens were affected by both the half and full clip treatment. Brown-feathered strains of laying hens are heavier than white-feathered strains, and a previous study by Provine and colleagues showed that brown-feathered hens were heavier and had less wing area to accommodate their mass, resulting in shorter bursts of flight compared to their close ancestor, the red jungle fowl. In addition to this, a study by Leon and colleagues showed that laying hens are already at their performance limit for low-speed descendant flight when hens had all of their feathers intact. So these results, along with ours, indicate that flight performance in laying hens is poor, and that an intact flight cover may be more important for elevated resource access in laying hens than previously known. And I just wanted to thank you all for listening to my talk. I hope you enjoy the rest of the talks, and I will be around for a question period if you have any questions, or feel free to send me an email at the email address on the slide. Thank you.
Well, thank you, Renee, for that great presentation. And it's kind of a little bit in line with Anna's question. So from your result, it really looked the difference between brown and white is also physical ability. There may be some, some motivation issues, but it looks from your data, it's really a physical impact.
Yeah, it does seem that way. From what I kind of talked about in the slides is the brown feathered birds are much heavier, and their wing area can't accommodate their body mass. So when we reduce their feather area by even just a half clip, which is a 30% reduction to the wing area, we still saw the reduction. So I think they're just less able to accommodate. Like you said earlier, the white feathered hens, they're just much more fit and they're a little smaller. So they were able to still maintain some of that upwards mobility, even when we did trim 30% of their wing area.
And to go about that, I see there's a question from Taniel about that body weight. And in fact, do you suspect the body weight is the major impact in itself?
I think it's one of the major factors, though I do still have questions about their physical ability as well as their motivation, like you mentioned earlier as well. I think there's going to need to be more studies sort of looking into it, but I do think they are much heavier. And I think it has a lot to do with the wing kinematics of flight.
Yeah, and the body shape is actually a little bit different. In the browns tend to be a little bit more rounded type of birds, whereas the LSL is almost like a thin
Yes,
shape. Yeah.
And the brown feathered birds also have those bigger legs as well. So, yeah.
Yep. All right. Is there any other question from the audience? Well, thank you very much. And by the way, I think this is a great, it's really good to show that, that trimming the feathers, may have a lot more impact when we transition to those non-caged type of system.
I totally agree. And thank you so much.
All right. Thank you very much. And